Hello and welcome to Pre-Algebra Lesson 10. And in this video, we're going to learn about the properties of multiplication. So for the lesson objectives, we want to learn the basic parts of a multiplication problem. We want to learn the commutative and associative property of multiplication. We want to learn about the identity property of 1, the multiplication property of 0, and the distributive property of multiplication. Okay, so I want to start out the lesson by just briefly thinking about what's going on when we're multiplying whole numbers together. So back in elementary school, when you first started thinking about multiplying whole numbers, you probably started out with learning the times table, and your teacher probably at the same time put something like this up on the board. So here we have 7 plus 7 plus 7 plus 7 is the same as 4 times 7. And essentially, if we look at an addition problem where the same whole number is being added, so in this case, that whole number is 7, right? We have 7 plus 7 plus 7 plus 7. We can use multiplication as a shortcut. So instead of writing this out each time and going through and saying, okay, well, 7 plus 7 is 14. 14 plus 7 is 21. 21 plus 7 is 28. We can do it more quickly with this multiplication. We have 4 groups, right? We have 1, 2, 3, 4 groups of 7. So we use that fact to say that, okay, this is 4 times 7, or 28. So it's a more quick way to perform a repeated addition. If we look at this example here, we have 9 plus 9 plus 9 is the same as 3 times 9, right? Because I have 1, 2, 3 groups of 9. So we know that 3 times 9 is 27. And if we went back and did the addition, we get the same result. 9 plus 9 is 18. 18 plus 9 is 27. Okay, let's look at 2 quick problems. We want to rewrite each as a multiplication problem and solve. So what I have here is I have 2 plus 2 plus 2 plus 2 plus 2. So essentially I have what? I have 1, 2, 3, 4, 5 groups of 2. So this would represent 5 times 2 if we do it using multiplication. And we know that 5 times 2 is 10. And if we go back and verify through addition, 2 plus 2 is 4, 4 plus 2 is 6, 6 plus 2 is 8, and finally 8 plus 2 is in fact 10. Okay, now we have 4 plus 4 plus 4 plus 4 plus 4 plus 4. So if I count these out, I have 1, 2, 3, 4, 5, 6 groups of 4. So this represents 6 times 4, and we know that that's equal to 24. And again, we can go through and verify this through addition. 4 plus 4 is 8, 8 plus 4 is 12, 12 plus 4 is 16, 16 plus 4 is 20, and then lastly, 20 plus 4 is 24. Okay, now let's talk about a little bit of basic terminology. So numbers being multiplied together are called factors. Okay, they're called factors. Then the result of the multiplication is called the product. So if we look at 6 times 5 equals 30, 6 and 5 here are being multiplied together. So those are going to be the factors. And then 30 is the result of the multiplication process. So this is the product, okay, the product. And a lot of times you'll hear people say 30 is the product of 6 and 5. Okay, now we have 9 times 7 times 2 equals 126. So these three numbers here are the factors for this problem. 9, 7, and 2, that's what we're multiplying together. And then 126 is the result of the multiplication. So this is the product, okay, the product. Okay, now let's talk about some properties of multiplication. And a lot of these are extremely straightforward. Some of them you've used before, you just might not have known the official name for them. So we're going to start out with the commutative property of multiplication. And essentially this just tells us that we can multiply in any order and not change the product. And we've already seen the commutative property of addition. Remember, we could add in any order and it didn't change the sum. Here, again, we can multiply in any order. We can multiply in any order and not change the product. So if you have 3 times 6, which 3 in this case is first, 6 in this case is you can think of as last, we put this as equal to or the same as 6 going first and 3 going last. Doesn't matter how you multiply. You're going to get the same answer either way. 3 times 6 is 18, and 6 times 3 is 18 as well. Okay, as another example of the commutative property, we have 12 times 9 equals 9 times 12. And again, you can prove this to yourself. If you multiply 12 times 9, you get 108. If you multiply 9 times 12, again, you get 108. So changing the order does not affect your product. Okay, let's look at an example real quick where 3 factors are involved. So we have 7 times 5 times 4 is equal to 5 times 7 times 4, and that's also equal to 4 times 7 times 5. So the same 3 numbers are being multiplied, 7, 5, and 4. We're just changing the order around. And no matter how you do this, you'll get the same answer. 7 times 5 times 4, 7 times 5 is 35, 35 times 4 is 140. Now if I do it this way, 5 times 7 times 4, well, we already know that 5 times 7 and 7 times 5 are the same, so we know we would get 5 times 7 is 35, and then 35 times 4 is 140. And then if I do it this way, 4 times 7 times 5, well, I could do 4 times 7, that's 28, and then multiply times 5, that's also 140. So again, it's very important for you to understand that when you're doing multiplication, and there's only multiplication involved, you can do it however you want. The order is never going to matter. It's never going to change your end result. Okay, now let's talk about the associative property of multiplication. So with this property, we can group the multiplication of 3 or more numbers in any order without changing the product. Notice that where we have 6 times 3 times 1, we have parentheses here around 6 times 3. And we're saying this is equal to or the same as 6 times, and now I have parentheses around 3 times 1. So when we say grouping, we're talking about putting parentheses around different numbers. So if you just have multiplication involved, you can put parentheses around different numbers or take the parentheses away. It's not going to matter at all. You will get the same answer. So if I look at 6 times 3 times 1, where 6 times 3 is inside of parentheses, we would do this first. And I know we haven't gone through order of operations yet, but whenever you have operations inside of parentheses, you start with that. So we would do this first. 6 times 3 is 18. Then 18 times 1 is 18. And just thinking about this over here, now we have 3 times 1 inside of parentheses. So we'd start with that first. So you would have 6 times the result of this, which is 3, right? 3 times 1 is 3. And 6 times 3 is 18 as well. So either way you do it, you end up with 18 as the answer. All right, let's take a look at a few examples here. We have 4 times 2 inside of parentheses, then times 8. And we're saying this is equal to 4 times, and then we have 2 times 8 inside of parentheses. So again, you want to start out with what's inside of parentheses first. So on the left here, we have 4 times 2 inside of parentheses. That gives us 8. So we would have 8 times 8, and that equals 64. Over here on the right, I have 2 times 8 inside of parentheses. So I'd do that first. So we would have 4 times 2 times 8 is 16, and 4 times 16 is also 64. So again, changing what we had parentheses around, or changing our grouping, did not change the product. It didn't matter that we switched what we had parentheses around. We got 64 either way. All right, let's look at one last problem. We have 9 times, and then we have 7 times 5 inside of parentheses. And we're saying this is equal to, here we have 9 times 7 inside of parentheses, then times 5. So again, start with the parentheses. On the left, I have 7 times 5 inside of parentheses. So we would have 9 times 35. And 9 times 35 is 315. On the right, I have 9 times 7 inside of parentheses, so I would do that first. 9 times 7 is 63. And then times 5 is 315 as well. So again, just to kind of wrap this up, I know this is a very easy topic, but essentially, when you think about the associative property of multiplication, it's really just telling you that you can put parentheses around whatever numbers you want when you're multiplying 3 or more numbers. It will not, in any case, change the product or the result that you get from your multiplication. Okay, now we're going to talk about two very simple properties. The first one is going to be called the identity property of 1, and then we're going to talk about the multiplication property of 0. So the identity property of 1 states that any number multiplied by 1 remains unchanged. And I think we all know this fact, because when you think about the times tables, it's always about, okay, 1 times 1 is 1, 2 times 1 is 2, 3 times 1 is 3, 4 times 1 is 4, 5 times 1 is 5. So you kind of learn that fact immediately, because that's the easiest one to do. So when we look at 15 times 1, we know we just get 15. Or if we look at kind of some bigger numbers, what's 97 times 1? Well, it's just 97. What's 3,866,151 times 1? Well, it's just 3,866,151. So a very easy property, and a lot of times, kind of in a pre-algebra test when you're first starting out, they'll throw this in there just to kind of trip you up. Oh, hey, this is a big number. How am I going to do this multiplication without a calculator? Well, you use the simple fact that a number times 1 is just itself. Okay, so probably just as easy, the multiplication property of 0 tells us that any number multiplied by 0 gives us a result of 0. So when we start out with 30 times 0, what's the result? It's 0. When we think about 25 times 0, well, the result is 0. When we think about 2,577,313 times 0, well, the result is 0. And a lot of times they'll put this question on a test, but they won't put it straightforward like that. They'll give you these numbers that are being multiplied together. So let's say something like 14 times 10 times 5 times 0 times 30. And a lot of students will see this and they'll go, oh, how am I going to do that without a calculator? Many of them could do it, but it would just take a long time. Well, you use the fact that 0 times any number is always 0. It doesn't matter what the result of the multiplication is through here, because whatever number that you get as a result, when you multiply it by 0, you get 0. Then when you multiply 0 times 30, you get 0. So when you see something like this where you have a lot of numbers being multiplied together and there's only multiplication involved, and you have 0 as a factor, you know that the result of that problem is going to be 0. Okay, now let's talk about a very important property. The distributive property of multiplication tells us that multiplication is distributive over addition or subtraction. And I have as a side note here that we use this property constantly in algebra. So now is a great time to learn and understand this property, because when you get to algebra, you're literally going to use it all the time. Okay, so I'm going to explain the distributive property by looking at a few examples. So we're going to start out with 4 times, and then we have 3 plus 6 inside of a set of parentheses, or we can think about this as 4 times the quantity, okay, the quantity 3 plus 6. One of the things I'm going to draw your attention to, and this is kind of a side note, is that up to this point, most of you have only used this to imply multiplication. So if I said, what is 4 times 3? You'd probably write that problem out like this, and you'd solve it and say, okay, 4 times 3 is 12. As we move higher in math, this symbol is going to go away in terms of multiplication. You won't use that anymore. And there's a variety of different ways that we can imply multiplication, and we'll kind of get to those as we move on. But for right now, I just need you to know that when we put a number outside of parentheses, it implies multiplication. So I could write 4 times 3 like this. Okay, I have 4, and it's directly next to a 3 that's inside of parentheses. So that's why I say 4 times this quantity 3 plus 6, because 4 is next to that set of parentheses. Okay, now let's talk a little bit about the distributive property. And before I even get into that, let's think about solving this problem without using distributive property. So I know we haven't done the order of operations yet, but that tells us before we do anything else to perform operations inside of parentheses. So we have 3 plus 6 inside of parentheses. 3 plus 6 is 9. So this would be 4 times 9, or 36. Now when we use the distributive property, we have an alternative way to get this answer. So 4 times this quantity 3 plus 6. Essentially what we're going to do is we're going to take this 4 and we're going to distribute it to each number inside of the parentheses. So we would say 4 times 3 plus, okay, plus 4 times 6. 4 times 6. So you have to remember to multiply by each number inside of the parentheses, and everywhere there's a plus symbol, or in some cases it's going to be a minus symbol because this works with subtraction too, you have to write that. Okay, you can't skip that over. Now, if we go through and we solve this, we're going to do the multiplication first because that's what the order of operations tells us. So we're going to treat these as separate problems before we add. So 4 times 3 is 12, then plus 4 times 6, which is 24. So 12 plus 24 is also 36. So either way, we're getting the same result. Okay, 36 either way. Now I'm going to erase all of this real quick, and we're just going to rewrite this, and then I'm going to kind of do this a long way. So 4 times 3 plus 4 times 6, and you can leave it like this or you can put parentheses around this like this. It won't change your answer if you know the order of operations. I just put the parentheses around it so that you know to do 4 times 3 separately from 4 times 6. I don't want you to get confused at this point. Now, if I think about the addition problem that we did earlier, 9 plus 9 plus 9. This is 3 groups of 9, so we said this is 3 times 9. If I apply that same logic here, I have 4 groups. I have 4 groups of 3 plus 6. So what does this translate to? 3 plus 6 plus 3 plus 6 plus 3 plus 6 plus 3 plus 6. Now, I know that the associative property and the commutative property allow me to reorder and regroup this addition however I want. So what I'm going to do is I'm going to write inside of parentheses 3 plus 3 plus 3 plus 3. I have 1, 2, 3, 4 of those. Then plus, inside of another set of parentheses, I'm going to put the 6's. So I have 1, 2, 3, 4 of those. So 6 plus 6 plus 6 plus 6. Now, if I look at it this way, it is clear to me how I arrived at this result. I have 1, 2, 3, 4 groups of 3, which is known as 4 times 3. I have 1, 2, 3, 4 groups of 6, which is 4 times 6. So you can see that this directly matches this. Using the distributive property was just a shorter way to get there, right? Because I know in the end I'm going to have 4 groups of 3, and I'm going to add to that 4 groups of 6. All right, let's look at another one, and we won't go through that long, tedious process again. We have 7 times the quantity 9 plus 2. So we're going to do this 2 different ways. We're going to do it the first way where we do 9 plus 2 first, because that's what's inside of parentheses. So this is 7 times 11, and that's 77. And then let's do it using the distributive property. So remember, I have 7 groups of 9, or 7 times 9, plus I have 7 groups of 2, or 7 times 2. And I'm going to put parentheses around each here so we know to do that first before we add. And again, you won't need that, but we haven't done the order of operations yet, so I don't want to confuse you. So 7 times 9 is 63. And then plus 7 times 2, that's 14. And so 63 plus 14 is 77. So either way, using distributive property or adding what's inside of parentheses first, we get 77. Okay, now let's look at one that involves subtraction, because this does also work with subtraction. So we have 8 times the quantity 4 minus 3. So working inside of parentheses first, I'd get 1. 4 minus 3 is 1. So we'd have 8 times 1, and that just equals 8. If I use the distributive property, again, I want to distribute this. So 8 times 4, 8 times 4, and then we're subtracting 8 times 3. 8 times 3. So again, I'm going to put parentheses around the multiplication problem so that you don't get confused. All right, so 8 times 4 is 32. And then we're subtracting away 8 times 3, which is 24. and 32 minus 24 is 8. So again, either way, we get the same result. Okay, let's take a look at one last problem. So we have 5 times the quantity 9 minus 4. Again, doing this where we do 9 minus 4 first. 9 minus 4 is 5. You'd have 5 times 5. That is 25. Using the distributive property, we're going to distribute the 5. So 5 times 9. 5 times 9. Then subtract away 5 times 4. 5 times 4. And again, I am going to put these multiplication operations inside of parentheses just so that you don't get confused. And when we get to the order of operations, which will be a few lessons from now, you'll learn that you need to perform multiplication before subtraction. But for right now, we know that we got to perform operations inside of parentheses first. So let's just put the parentheses around it and work with that rule. So 5 times 9 is 45. Then minus 5 times 4, that's 20. And then we do this subtraction, 45 minus 20 is 25. So again, either way, we get the same result, either by doing what's inside of the parentheses first, or by using our distributive property, where we distribute our multiplication to each number inside of the parentheses.